The last stretch. Hi, everybody, dear colleagues, random people on the internet who are going to turn this off after a minute. Everybody. This is a time to ask ourselves at the end of this awesome conference, Quo vadis, which in Latin means, in exact translation, where the heck are you going? Where the heck are we going? This is the question. First, I'm going to talk about aspirations, not the medical procedure, but our aspirations with D. What do we aspire? What do we want? D has always been a language of great ambition, of unbounded dreams that not only Walter and I and other direct contributors have had, but pretty much all core contributors who have tuned into D have started to share this common thing. We don't want a perfect language, but we want a language that is comprehensive and comprehensible, for that matter. So we build on principled and practical grounds. This is important because many languages kind of tend to err on one side or the other. And Walter being a practical guy, I'm the principle guy, I guess. We're both very much anchored in the practical realities, but we want to bring a principled approach to solving problems. So this yin and yang has guided the design of this so far, and I see them guiding in the future too. So very simple things, very practical things, such as slices, approach to modularity. Things like the whole support for generic programming, which has been discussed so much. Error handling done right, scope. Other languages have started picking up scope, which is very satisfying to us. A lot of other languages either try to do it in a library or try to do it in the core language. We believe that things like this are innovative solutions that are at the same time practical and principled. The entire system of qualifiers, immutable, const, and shared, has had a difficult birth. But I would say right now we're at the point where we can say we can reap their benefits because they are pretty much necessary. They are a consequence of us wanting to address both imperative and functional programming in a principled and a practical manner. The approach to safety was also a combination of these requirements which are often in tension, which is, you want a system language, but you also like safety, so what you gonna do? So we have these two worlds, and then we have the zombie netherworld of trusted code, but all tend to work together for programs that are verifiable, maybe except for a few small parts. Well, we have some, I can't talk about these features without talking about some meh features, and I think all of us have a few. Can you tell me a few that are not on this list? Probably everybody would raise their hand if they thought for a second, but definitely there are a few features that are just there. Property has been widely discussed as a sort of imperfect approach. That's not even very principled. Practicality is being debated. The whole interplay of synchronized and shared is tenuous. We have operator delete in the language. We have a keyword for doing unsafe things. To that I would say, here's the thing. I think it's fine to have a toilet in your house. You don't have to put it in the living room, okay? Because people come to me and say, oh my God, I can't believe you're deprecating delete. I can't believe I can't delete objects. I say, yeah, sure, you don't have to have a goddamn keyword to do it. Yeah, there's going to be an obscure function somewhere in the library. If you're really motivated, you're going to find it. But it's not going to be a keyword. It's not worth, this is not the ethos of D. We don't want to do unsafe things with a keyword. Qualified possibility, it's been a tenuous issue that we have ideas on how to design around. So probably this is going to be the subject of a language change in the form of a non-breaking improvement. There's been also this whole autoref and R-value references and binding temporaries to references, all of this, this thread, all this notion, which we have, I believe actually at this conference, at the end of an extremely violent discussion between Manu, Walter, myself, and a few others, it's kind of led to a miraculous solution, quite, to be honest. I mean, you know, one day before, I couldn't have thought it's going to be so nice, and I'll be very happy to share more about this as the conference winds down. So today, these are in the category of meh features. They're not great. They're not very anything to write home about. For it reverse, by the way, it's just one of those things. So why don't not make a library that reverses the iteration range and does it better and such things, right? Anyone want to add to this list, by the way? Anyone? Add to this list. There's so much to add. Okay, destroy, yes. Complex numbers. Actually, they are officially deprecated. So I meant to include them, but I didn't because we already made the right step, at least at least officially, so to say. De jure, maybe not already there, but de jure we did it. Yes. Traits. Underscore traits. I would say they are intentionally ugly because they are just support for intrinsics in the standard library. People should not be using underscore traits in end user code. They should all be presented to the user in standard library artifacts. But I do agree that's a mechanism that is it's intended. It's intended to be copper and lead and stuff. It's not porcelain there, right? Yes. Associative arrays. Yeah, I meant to put that here. Associative arrays are sort of a curse and a blessing. They are a very convenient feature. At the same time, for a programmer who's very interested in performance and in predicting, the allocation patterns of a program, those are not going to work all that well. I do consider, however, that library solutions can fill the need there. Any others? Okay, we're done with bad features. Terrific. Can't believe it. That was easy. Well, the most interesting part of D, in my opinion, is features that don't exist, but they work, which is a sort of a paradox in terms. But here's what I mean. Consider attribute inference. So there's attributes in D, and then there's inference thereof. There's inference of attributes. So you don't need to write them, but they work. So this whole thing, you kind of write your code without the attributes for a large part of your program, and it just so happens that the compiler under the wraps is going to infer them and use them for a variety of good reasons. I think this is going to become a meme in the D community. Like everybody and their sister has mentioned in their talk CTFE, compile time function evaluation. This has been absolutely humongous. And contrast that with languages that defer everything to runtime, which is runtime function evaluation, mind you, or languages that define a whole additional sub-language with odd rules for compile time evaluation, viz. C++, right? So C++ has one language to write like regular code, and then there's a whole sub-language and its respective subculture, of which I'm part of, for writing compile time code. So it's a very fractured approach. And this whole idea that you get to use the same language for both runtime and compile time computation has been an absolute slam dunk for D. Scoped imports. This is one of those things, turtles all the way down. This is one nice guiding principle of D, turtles all the way down. Scoped imports means, you want to import something in a module, and you can import it at the top of the module, right? This is the sort of the traditional approach. But recently, we've added capability of, you know what, I'm in a function, I'm in a scope, I know an if, I'm in a for, and I need this one function here. You get to import the module right there, and right there, in the middle of a scope. And then you see the symbols, and it's efficient and everything. It's not going to be imported multiple times and all that. Of course, if you find yourself importing the same module many times in many scopes, you want to hoist it and put it at top level in your module, because that's the reasonable thing to do. But this kind of thing is a feature that doesn't exist, because it removes the limitation instead of adding anything. It removes an unnecessary constraint that would surprise the beginner. They would say, you know, if I, you know, like the British say, if I like tea and milk, why don't I like them together, right? If I can do import at top level, why can't I do import in the scope too? That didn't quite fit, but you know, okay, bad metaphor. VRP, the whole value range propagation. So again, here we had to solve a very weird problem. This assistance language, it has 8 precise integers, 8-bit, 16-bit, 32-bit, and 64, right? Even there's keywords for 128 when the time comes, right? So you're prepared for the advent of the apocalypse, or whatever, right? So we're prepared, we're kind of there. And the multiplicity of these integral types makes for extremely painful conversion rules, right? So you have, oh my God, so I have these integers, oh, this was an 8, and this is a 16, and whenever you add them, they get automatically promoted to 32-bit because that's what the CPU likes, and then cast them back to whatever, and so on. And here, languages tended to take 2 approaches. So what does C does? C and C++, what do they do? They promote to int, but you know, what do they do when you try to cast like an int back to a character? Right? You can have a long, and convert it to a char, and the comparison is like, okay. Right? There's huge truncation going on. So what do C# and Java do? A throw, not that bad. So what they do, so they said, you know, we're not going to allow truncation without the programmer knowing about it. So what we're going to do is, ask them to do a cast. So therefore, the typical C# and Java program that is concerned with integer sizes is going to inevitably have a bunch of casts. It's going to insert cast here, cast there, and Walter and I thought, you know what, so we have a dual problem. Problem number 1, we don't like what C does. Problem number 2, we don't like what C# does. Problem number 3, we design a generic language that's intended for generic use, and as soon as you have cast in that language, that's cast and generic, they don't go together, right? They're unlike tea and milk. How about that? That did work. Okay, so we had this problem, and all of a sudden, this idea came in the air. I forgot who mentioned it. And it was, oh, why don't you do this thing that actually optimizing compilers do? It's a backend kind of thing. There's this whole value range propagation thing that kind of, the compiler remembers what are the limits, the possible limits of the value, and conservatively is going to kind of cast whenever it's possible to do so. So you don't need to cast yourself, but the compiler is going to track values, and it's going to take care of it. Which means very few casts are necessary, and the compiler is going to tell you, is going to force you to cast when needed. So this is safe and at the same time much more convenient. So again, this is a feature that doesn't exist because the user doesn't need to learn much. It just happens to work. And actually, when we introduced this, we were very pessimistic. We said, well, maybe it's going to improve a couple of cases. And we compiled like the whole phobos, like tens of thousands of lines of code, and we had like to fix like 2 places. And everything else worked out of the box. It was pretty much amazing. And last but not least, relaxed purity, which is another invention by Don Clugston. And I'm going to actually dive into this because I think the Keynote is not good if it's just fluff. We've got to kind of write some code, right? We want to spin some code. So let's do it. First of all, I'm going to start with defining the archetypal factorial function as people define it in function language tutorials, right? So we take an unsigned integer, and and we have the standard loop, right? And what's the problem with it? If you can read, you know, right? What's P space? Now that is a question. Polynomial space, right? So it's polynomial space because this is not the last operation in the loop because there's a multiplication after it. So essentially you have a stack depth as large as the input was, right? It's polynomial space, linear space, right? And this is one of the 3 examples that everybody who teaches functional programming is going to give. And these 3 examples are the factorial that's P space, so it's bad. The Fibonacci that's double exponential, so it's bad. And the quicksort that's not quicksort. It's not quick and it's barely sorts. Okay? That's quadratic and in the average case. It's just absolutely terrible. So these 3 examples miss it. I mean, here's the thing. There's this wonderful functional programming thing. And let me teach you with 3 examples. I'm going to choose the absolute worst 3 examples that are possibly imaginable. Right? That doesn't sound right. Doesn't sound right at all. So actually, let's fix this. Because I do believe functional programming is awesome for a variety of reasons, but I think it's very badly taught, and I do believe we can improve a lot of things about it. What would you do about it? Make it a loop. Well, yes, Eitan?
This is actually a great example because you can talk about tail recursion optimization.
This is a great example because you can talk about tail recursion optimization, or in this case, the lack thereof, right? All right. So, well, the nice thing with factorial, so kind of to put the carrot in front of us, is that it's pure. So actually get to compile and run this code, it's pure, so you know that it's going to always yield the same result for the same n. And this is a wonderful property. Good. Do I need to convince anyone that pure is good? Purity, and it's just like in life, is good, right? Let's fix it. And the way you fix it is you define an inside, a function inside factorial, which I call conveniently crutch. Okay? And in that case, you're going to go, well, crutch, and this is the partial result that I'm going to thread through the crutch. And I'm going to return blah, 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 or end recursion. And what's the difference between this recursion and that? No, accumulator is not the right word.
You're returning a call.
I'm returning a call. It's a tail recursion, yes. Thank you. It's a tail recursion. So I'm either using this, it's a condition, return, and tail recursion. Awesome. The compiler can figure, actually provably is going to be able to make this constant space, right? And then we return crutch, and we see this guy. And this whole thing is a sham. People say, oh, look at how nice you can do, tail recursion, and, transform a non-tail recursive function into a tail recursive function. And I say, you know what, I don't care for this crap. This is a lie, because what it does, it threads state through a function for a reason that is very difficult to justify with a straight face. Okay? Very difficult. So this actually is kind of a, it's a dribbling. It's a hat trick. So look at how I can make this whole thing work, and this is what you're supposed to write for a fact, the nice pure factorial, etc. Not good. So what I think the honest factorial is, if you take a math book, and you see that big pi, it's a pi from I equals 1 to n of I. And this is what you should be doing. You should do an iteration, because this is what the book does. This is what the mind does. The mind doesn't recurse. This is what you should be doing. This is what is natural to do for this particular algorithm. There are others that are much more natural recursions, but this is not. So in that case, what you best do, what you're most natural doing, you're going to say, well, I'm going to multiply a temporary, a running accumulator, and then I'm going to return it. But this function is no longer pure because that I gets repeatedly mutated during the computation. You agree it's not pure? Well, then allow me to retort. What does a pure function look like? A pure function is as pure does. In your room, at your place, behind the closed curtains, you get to be a bit dirty. You have that right. This is a democracy issue, really. Okay? You get to do things because this function is, from the outside, very pure. Has a very nice property. Well, pure functions always return the same result for the same arguments. Nobody said about what they do in their own bed, okay? And what TV they watch, I guess. No reading or writing of global variables, but global immutables are okay to read, not write, of course, right? That was a joke indeed. No calling of impure functions, so the whole thing holds water because as soon as you escape purity, you get like, really dirty there. You don't want to do that. But who said anything about local and transient state inside the function that's only computed from the input, it's used temporarily and then thrown away? So we get to this whole thing of, well, how about the transitive state issue? Well, what if I have some state that has some pointers in it and stuff, kind of, I have state, but it kind of accesses a whole graph, a whole tree, a whole graph in general of memory. Well, this would be a simple approach. Let's just disallow it. But the more useful thing to do is to relax the rule. And that's how Don invented the whole notion of weak purity, which probably is not a great, it's not very conducive to jokes, but weak purity sounds pretty good. Well, I'm pure, I wish I was purer, but I'm not all that pure. So that kind of thing. You get to operate with transitive closure of state reachable through parameters, which is fine. So you get to kind of, as long as you can, what you compute starts from the parameters and access memory beyond that, that's fine. So this is not functionally pure, but it's an interesting superset of purity. Very interesting. And what gets some people confused and what is sort of beautiful about it is that there's no need for a weak pure annotation because it's only the signature. You write pure, it takes mutable data within directions, it is weak pure. This plus that is flash is weak, right? So we got to this notion of weak purity. And it turns out, so people started kind of thinking about it and using it and kind of playing with it. And it became obvious that such functions that are weakly pure are a great helper for really, really pure functions, like strongly pure functions. And this is terrific. I love that. This is an awesome, innovative solution to a difficult problem. And you get to actually write then factorial, pure, and even operating on user-defined types, which have indirections and all that stuff inside of them, and have the compiler say, OK, rubber stamp, this code is good, works, and let's go with it. To be honest, Don, you got to kind of annotate with pure some of the big int primitives and stuff like that. So this doesn't work today, but I kind of hacked into the code and verified that it does work indeed. So not everything in the standard library is purified yet. This is nice because now we can have a very simple mental model. If our parameters are able to reach mutable state, then we have this whole weak pure, relaxed pure thing, which means it's you can access memory, you can change memory, but you can't change globals because globals are not reachable through your parameters, right? They're kind of there, right? You can't do I/O or any impure functions, and of course you can't call any other pure functions, not only I/O. But if parameters cannot reach mutable state, then you really have Haskell grade observable purity, even though the function can do imperative things inside. So as long as as long as the implementation imperative part is local only and transitory, then there's nothing to do. Microphone.
Yeah, it doesn't only depend on argument, because if you return, for example, is an object, you have equality of the object, but you don't have identity of the object that is the same.
I didn't get the beginning.
If you call the same function with argument that can't reach any mutable state, you don't get an S-scale grade observed purity, because if you call the function twice, you will get 2 times the same object.
If you allocate new objects.
Yeah.
Yeah, but
you won't get the same object.
Yep. No, absolutely. But this whole new fresh memory thing is a classic. As long as you don't compare addresses, it all applies. So this is a known issue, even in kind of certified pure languages. All right, so I wanted to kind of get deeper into this to illustrate that we are looking for solutions that are comprehensive, that that people can use to solve real problems with ease. But however, we don't want to go the simplistic route and say, you know what, I'm going to ignore this problem exists, right? And this does not make the language bigger. In many ways, it makes it simpler because, it just works. A lot of stuff just works. It's just annotated with pure, and the compiler takes care of the rest. So I would like to emphasize that D is not a big language for what it does. It's a comprehensive language. And to be comprehensive being comprehensive does not entail being large. Right? It just needs to capture a variety of modeling scenarios and a variety of problems and their solutions with a relatively small, compact universe. At the same time, we're not looking for perfection here, because we understand that the perfect language does not exist, the ideal language does not exist, but we do believe that comprehensive is something that you can't be like infinitely comprehensible, but this is something that you can live into, right? So that brings us to memory allocators. So I've been badgered repeatedly by people on news groups and here at the conference, and I'm still standing, about memory allocators. So the situation is we have the containers design. So, Adam kind of complained here on stage about containers not being quite there. And, it's clear that we need to do something about it. And all of that something is blocked by work on memory allocators. And let me explain to you why I'm not done. Let me explain to you what kind of life I live, right? So I wake up at 9 a.m. I'm kidding. So we want a comprehensive design. It became clear to me from the input from the community that a simple allocator design does not work. It's not going to be enough. So containers without allocators, people said, no, we don't care for that crap, okay? And then I was like, well, what do you want? Well, we want regions and all this good stuff. So we don't want a perfect allocator design, but we want one that works. Designing an allocator that doesn't work is easy, as we have seen in the C++ community. Actually, it's very interesting because I interviewed a number of people in the C++ community, the biggest wigs I could find, right? So I interviewed them, and I was like, why do you think C++ allocators failed? And the question is, nobody knows. Nobody knows to the extent that some people believe it's a solved problem. You're supposed to laugh at this point. I think it's really funny, right? It's so confusing that you think, actually, we kind of took care of that, right? So it's extremely tenuous to do anything with allocators in C++, so they're definitely not up to snuff for the kind of demands that we want to put them through in the D language. So I had this fear about you do whatever you do, and you take the wrong turn, and whoop, C process allocators. Oh my God, right? We don't want to take that wrong turn. So let me share with you. Let me get this off my chest to share with you what we're looking for. We're looking for a comprehensive allocator design. And here are the archetypes that we have in mind. So the simplest allocator, which is like everything's going to live forever and be young forever. Awesome. Garbage collector. You just allocate the never free. Everything just is there, right? And the whole garbage collection thing is the practical way to maintain the illusion that everything lives forever, right? So there's this whole green food kind of thing. Remember that movie from the 50s? All right, so then we have garbage collected plus manual free. Walter.
Shouldn't that be garbage collected plus delete?
Delete's going. So these are distinct. Why are they distinct? Because this is not safe. This is safe, this is not safe, right? Awesome, this is an interesting distinction because we want sometimes containers that are safe. We some other times don't care about safety. We want the extra oomph that free gives you. So I'm garbage collector plus manual freeing, which is a nice thing. We want the straight malloc-based allocators, and we want very interestingly the region-based allocator. A region-based allocator is a pool, right? Scoped allocation. So you define the allocator, has a scope lifetime. You allocate stuff from it, and when the allocator goes away, everything goes away in one shot. So that's a region-based allocation, right? So I want you to picture what it takes to put these under the same API and make it fly, okay? It's difficult, but that's not all. But wait, there's more. I was at the wrong but, right? Okay, so we have this whole archetypes kind of thing. So we need to kind of think along these dimensions, unify them under an API that's at the same time efficient and brings the bread home and everything, right? So then we have yet another issue. We have the composability issue. Well, we want to compose allocators because, for example, in my own the project I'm working on at Facebook here, the most awesome thing since sliced bread, hot water combined is free list over region. This has performed incredibly well. So you allocate a region, and on top of it, you have a free list, right? And the free list kind of allows you to sort of delete the kind of free memory, and then the region kind of takes care of it all in a shot. So I'm seeing thumbs up. I hope it's the thumbs, right? Not any other finger. So there's a related word that kind of proves this works, right? Heap layers, you may want to Google for it. It's a very interesting project. So we want to compose, stack allocators on top of each other. I want a free list on top of a body heap, on top of a free list of this size, on top of the free list of this other size, and it should all work real fast, right? But wait, there's more. We want safety. Remember, I discussed this whole free thing. So some allocators are safe, some are unsafe, and some, very interestingly, can be made safe. And this is like research. I mean, people write papers on this kind of stuff. Like the LLVM people have a paper on that. And this is kind of complicated. With a combination of static and dynamic checks, you can do it. You can make it. We can make regions safe. And the question is, how hard are you going to work at compile time versus runtime versus programmer time? There's a language that does this safely, which is safe regions in a language. Rust. Rust is kind of, Rust is sort of the newest, but the first language that did it was Cyclone, a C dialect written by Dan Grossman, was my co-advisor back in the day, and he defined Cyclone to have safe region-based allocation, and it required careful annotation by the program. It didn't succeed because it was a bit hairy for this to ensure this kind of stuff, but it was all statically proven and very nice. All right, so here's the thing. I do have an image of how that design may look like. I do have a sort of a general idea which I wanted to share with you. It should go like this. Okay? This is about the general idea here. All right. So next I'm going to speak about vision. So where do you want to go from here? So I kind of tell what we are about. I just told what we are about, what's our ethos here. And next I want to talk about where we're going. So what are the next steps we're going to have to take? And I'm going to open with a fable, which is present in different cultures, in different forms. This is very interesting. In a politically correct form, there's a neophyte. How do you pronounce this? Neophyte. Thank you, Jonathan. Neophyte, Benjamin. Neophyte and the guru. And the neophyte goes to the guru and asks, what should I do to be a better person? And you can imagine the guru, like, shaved head, kind of rocker type, sits in a lotus, right? That kind of guy with a red robe, whatever. The guru says, do what a good person does. And this is present, like, sometimes the guru is a monk, and sometimes the neophyte asks for a date. And, there's different versions. That's not the same, right? So sometimes, it's how can I be a better believer? And do what a better believer does. How can I be more confident? Do what a more confident guy does. How can I be more beautiful? I guess, get some makeup, right? So that doesn't fit the pattern. But what's interesting for us about this is that we get to ask a similar question. What should we do to scale to 1 million users?
Do what 1 million users do?
Do what 1 million users do. That was unexpected.
Do what somebody with 1 million users does.
Do what somebody with thank you. Do what something with 1 million users does. And actually, this has worked spectacularly for Facebook as opposed to Friendster. So, back in the day when there's competition, Facebook always scaled first, got users later. So they scaled from Harvard to a few other universities to national to international and everything. And it was always preceded by scalability effort. Friendster, the day they died, the day the site died, it had 38 seconds time to interaction. So you click on something like a crazy guy on Friendster, and it takes 38 seconds for something to happen. They accepted users until the day they crashed. They accepted users like forever, right? They were like, yes, let's get more users. And of course, we know what happened after that, right? Facebook was very conservative about growth, but was always scaling first. So Facebook acquired 1 billion plus users because it did what it takes to have 1 billion users. Now let's scale back by 3 orders of magnitude to 1 million users. And what do we need to do as a language with 1 million users? We have 10,000 right now, or maybe let's say 10,001 because we just got a convert right now in the room. What should we do? Well, it means we need to work on stability. We need to work very hard on quality. We need to expand our platform base, and I'm very happy the GDC and LDC people are here. And we need to have what I call operational professionalism. I'm going to talk a bit about each. So in terms of stability, I got to say, right now we have more of a PR problem than a stability problem. Because D is useful. I mean, people have like 500,000 lines in D, or whatever millions you have, you can't tell. So people have large D code bases. And clearly D is usable. So, to answer Chuck, when does it get out of alpha? It's out of alpha, but nobody knows. That was a joke, you're supposed to laugh. But stability is something that we need to really be on top, like white on rice. We need to be on stability really, really carefully. And we need to reduce the bug count. We need to essentially work on anything and everything that means stability. Because that's what 1 million users are going to ask for, right? Quality. We need to have quality tools, quality implementation. We need to have, even the website should be better, right? Everything should be there. we need to expand our platform base. And what I mean by that, I mean ARM, right? I mean more Unix varieties. I mean, everything and anything and everything that D can run on. There's iPhone, there's phones, there's stuff that's embedded systems. There's a lot of stuff that needs that could use D support, and we need to kind of grab them. We need to have those users. Many users in embedded systems, they use whatever the platform offers sort of in hatred. They hate it, but they use it because there's nothing else. We want those folks. We love them, right? Operational professionalism. So let me kind of tell you one thing. Like, we come here, we talk, we kind of have a laugh, we eat, we go home, right? At this conference. I gotta tell you, like, for the AV support people, for them it's a military operation. So they come, they put your bulletproof vest, they wire like you're a FBI agent, and then they're like, you can hear in the back the AV support guys, they say, the question, turn on microphone 2, pan, zoom, zoom. Oh my God, feedback, abort, right? And then they have a drill for when the battery goes out, they have a drill to fix it. So there's a drill, and it's kind of fix this guy's battery real quick. So they have a routine. They have professionalism. There are people at work who do their job for a good conference, right? So this kind of stuff we need to have down. We need to have this operational professionalism, like to do our work real good, have a real operation, because if the AV people were a seat-of-the-pants operation, this conference would have sucked. We'd be like, oh yeah, that microphone doesn't work, and all that stuff. By the way, so at the point, here's the thing. During Andrew's talk, so the sound didn't work. Your video, right? The sound wouldn't work. So he put a microphone, and it worked. So I said I'm not gonna give crap to the AV people for that. It was okay. But then I'm about to go. I'm about to leave home. And the two of them are here with the guy in the back. And they're fixing the problem. Nobody told them. If they were a Billy's kind of AV crew, they'd be like, well, it's gone. We're done. Let's go home. No, they're working on it to make sure it never happens again. This is the kind of what we need to do. Right? So it can't happen that I'm the only guy who can update the website. It can't happen. It can't happen that Walter is the only one who can push bits to the server. It can't happen that we have a zip that's broken on the website. This kind of stuff, we are not allowed to happen, because this is exactly what you do when you don't want 1 million users. If your goal in life is to not ever have 1 million users, you're going to do that, right? We should not do that anymore, okay? I'm thinking of two main prongs in going forward. One is we need to play into our strengths, and the other is to cover our weaknesses. So there's two main areas that I see we should push forward in. As far as our strategic strengths, here's what I believe is really important for D. We have an active community. We should make it as active as it gets. Push for more content. Push for a more welcoming community. Push for more content, more articles, more blog posts, more talks. We have an incredibly fast turnaround. This should stay. So it's turn on, you compile, you run, you debug, you edit, and so on. It's an incredibly fast turnaround. And the funny thing about this is it's fast turnaround of fast code. Because you can't have fast turnaround if you generate crappy code. Right? But you have fast turnaround that the code generator is also fast. So this is sort of kind of amazing. Well, do I need to kind of... So this is huge. This is strategic for us. Something that's not mentioned very often, actually it was mentioned a couple of times in the conference, so DSELs, domain-specific embedded languages. I think this is something at which D can excel. The sort of things like I can parse SQL during compilation and kind of bind columns and whatnot. I can write this grammar in D and kind of have it in EBNF format and generate a parser for it just like that. Generate XML grammar, not to mention regex and all that stuff. Libraries is a great strength of D because it's so expressive, so you get to write good libraries. Of course, there's a weakness, we don't have many of them. Ranges and algorithms, these have been like complete slam dunk of D. And I think we should kind of push for that. Actually, I think we should let people know about like what great things can be done with ranges and algorithms. By the way, what do I mean by bulk processing? Bulk processing. It's not parallel computing or bulk processing. More data than you have RAM. No, what I mean by bulk processing in this context, when I say ranges and algorithms, I mean it's this approach in which instead of loops, you kind of have all of these composable functional entities. Like, I want to change stuff, and I'm going to filter, and I'm going to sort, and I'm going to, unique, all of this good stuff. Link, C# link, Microsoft link style. So every modern language and framework nowadays does have something like that for bulk processing. It's all the rage right now. And I think many people say, oh, it's actually all this functional programming thing. And, I agree. But the real thing that's going on is not the functional aspect as much as the bulk processing aspect. Because, for example, Scala is not functional, but it does do a lot of bulk processing. Concurrency and parallelism, I think we have a very good, solid foundation there, and we need to build on it. So D should be framed as a one-stop shop for getting things done. Just like Walter said, a good airplane looks like it wants to fly. D should be looking like a language that wants you to code in. Was that grammatically even close? So D must look like a language that waits for you to just write code in. So it should be willing to fly. All right, well, that was the nice part. But before I get to the weaknesses, let me show you some. This is, it's very old at this moment. It's sort of after David showed his own benchmarks, and this is old. But my point here was that we are faster than the fastest in the world, and the sad part is nobody knows about it, right? So faster, I mean, it's a nice position to be in, like to be faster than the fastest there is, with great kind of, brouhaha, like V8 is so awesome and it does all these good things. But we do even better things, but nobody knows. Well, now you know. I mean, since David's talk at least. So this is the kind of thing that I'm looking into. This was enabled, this whole Fred regular expression static compilation. This is something that we can do that nobody else can. And I want to continue in that trend. Right? We should be going forward there, right? On to weaknesses. Well, as I mentioned, quality of implementation is a big weakness right now. We need to be very, very good at not having bugs. And even more important, we should sort of, this is a PR problem as much as it's a technical problem. Because anything that's a reputation thing, or disreputation if you wish, is going to last for 1 year after the technical problem has been solved, right? So this is one of those things. Formal definition of the language. I do think we should push for a better, clearer, more precise definition of the language. We can't have the implementation define the language. We really should push for this. A big weakness is available libraries and package management. So this whole, we don't have a package manager, everybody else does. And for Python, for example, whatever you want to do, there's a library for it, and you just write a command, and you got it, and all that kind of stuff. So we need to actually focus on this a lot more. Not to mention ecosystem tools. Don was complaining a lot about IDs that should not crash, which is like, kind of, I would say it's a simple requirement. It's not so difficult to not crash. It's not, it's reasonable to ask for it. So, not to mention this whole documentation and tutorials thing, which has been repeated a number of times at this conference. So I'm not going to insist on it that much. But actually, let me kind of sit on this a bit and mention some. I don't think there's understanding in the D community, especially at the core, how important blogs, articles, and Reddit and Hacker News are. I don't think it's understood. So we have all these great things, we do all these great things, and occasionally somebody makes a, the 3 pages post in the forums, which is wonderful. But the forum kind of the posts go away, blow away, and then that was it. Yeah, 40 people know about it, and that's about it. So I really encourage you to put your mind to writing more about the great things you're doing with D. And for example, I am flabbergasted that when I announced this conference, people using D in companies, in corporations, came out of the woodwork. Oh yeah, I'm doing this, I'm doing that. Let me give a talk. I've been very happy to invite a few people especially from Germany for some reason. Like they love D. I don't know why. Yeah, actually, Amazon.de is selling a lot of the TDPL. So there's a lot of things going on, but I had no idea. And Walter and I are kind of supposed to be in touch with all that stuff. So there's a disconnect here that I wonder how to fill. And it becomes part of this. Like I use D at this corporation which crashes subway trains in Munich, and here's what I did to crash it, right? So we need that kind of stuff. Last but definitely not least, process and roadmap are huge, right? We do want to have a well-defined process. Again, 1 million users. If you have 1 million users, what kind of process would you have to support them, right? And what do you have? How do you notify them whenever there's a change coming, whenever things are happening, whenever we're breaking their code, presumably not too often, and things like that. So we need to really focus on that. Walter and I are completely committed to that. Now, let me kind of tell you a funny story. When Walter wrote his talk, he kind of sent me the slides, but he knew I'm not going to answer because I was too busy. So he sent me the slides, if you have any comments. When I wrote my slides, which I finished like, I don't know, an hour ago, when I wrote my slides, I didn't even send them to Walter. And we're supposed to kind of know what if Walter's like, whoa, I didn't think we'd want to do that kind of stuff. So one very nice thing about the cooperation between Walter and myself is that we see eye to eye in so many things and so closely that we actually can be confidently saying that this is what we both want, which is remarkable. I think that's great. We both have failings, we both have many defects, but I think sort of, our collaboration is better than kind of we cover each other's failings and stuff like that. So I'm very happy about that. Last but definitely not least, what is the best feature of D? Question. Destroy.
Don and I figured out at lunchtime why D is so popular in Germany. If you look at German cars, they all have a D on them. So D is the national programming language of Germany.
This is awesome. All right, I had a theory too, but okay. The Danish people, what's wrong with the Danish people then? We should talk to them. Everybody in Denmark does PHP and C++? All right. Okay, so last but not least, to be honest, like the best feature in the D programming language are the people. There's the people in this room, right? And then there's people who couldn't make it, and I would like to single one out. I really wanted to mention this one guy. Who's he? Kenji Hara. Let's give him a hand. He's gonna go on tape. Kenji, absolutely fantastic contributor. So the people are like our really, 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 really best feature. And this is my pledge to you. We're gonna make this happen. It's gonna be an annual event. So we have a number of options. We're looking at a number of things. As soon as this is done, and as soon as the pain and turmoil of it is over in our head, we're gonna actually start work on the next one because we believe this is awesome. Yes.
Is this where Walter says, "Wait, what?"
Yeah, exactly. This is the part where Walter says, "What the hell?" So we're going to make this an
we're in
annual rallying
agreement on
point.
that.
It's not going to be an isolated thing. And we have, we have a number of options. And definitely, so this must happen. There's no negotiation that, there's no doubt this is going to happen, right? So we're going to meet again next year, hopefully much more many than that, right? OK, so the people connection has it that any community really needs to be nurtured, needs some specific kind of non-technical things going on for it. So we should all focus on increasing participation. We should talk our colleagues into looking at D. We should kind of, again, the whole articles and blog posts angle. And by the way, so I'd be very happy if more of our corporate users would be on the forums, kind of, telling things, asking questions and whatnot. There's not a need for quantity, but I'd be really happy to know that, people are using D here, there, and everywhere, right? Welcoming new community members, I think we're good there. We could be a lot better, but I do think we're pretty good. I'm increasingly thinking of something like the D Summer of Code, which is sort of a paraphrase of Google Summer of Code. We're thinking of actually initiating this sort of student project, 3 months over the summer, and the student gets paid. I'm gonna pay the student if the project is compelling. So we're considering something like this, and we should talk more about this. We should find some sponsorship of some sort, but if not, actually, again, I'm willing to actually pay for a good project to get done. And we have this great forum which comes in, all these forums like online and mailing list and an NTP, you name it, which is a great place to hang out and discuss language design. Let me give an example, actually, of great trolling that I loved. So there's this guy. This is the title of the post. I'm not kidding. So you actually browse here. So D is totally useless, and we tried to rewrite this. I was shocked. Toy in outer space, program in schools, hello world, and that's it. Now I understand why D doesn't have the popularity, etc. Right? So this guy comes, and what's the appropriate answer to this? It can be told in polite. It cannot be told in polite company, right? But then actually people kind of reply to the technical aspect. He missed the header, library didn't work, whatever. Things on Windows were weird, and people are writing kind of And then his next post was, well, thanks to this guy, kind of did some work on this, and we give it back to the community. And I hope it's going to be included. This is our first draft and everything. What this reminds me of? Tom Sawyer painting the fence. Remember, like Tom Sawyer is painting a fence, and kids come and try to make fun of him. It's like, oh no, this is really cool, painting a fence, right? So then kids pay him to paint the fence themselves. So yeah, this is a great troll, I would say. This is pretty awesome. So this is the kind of thing. Focus on technicalities. Walter and I are completely apolitical. We don't even, it's just like be the best you can, and you're going to thrive in our community, right? This kind of should percolate really down to all of our contributors. So this is the kind of atmosphere that's awesome. So I talked a lot about the D community and what it should be about and what it could be about. And again, there's not enough times I should say this. Focus on making the world know about the great things that you're doing with D, or your ideas, anything. Anything that is interesting about D, and there's plenty of it, should be known to more people. I think we're at that point right now. We do great things, they're possible, but not everybody knows about them. The second thing that I'm thinking about, we should increase our participation and cooperation with is the academia. So the academia does research on a variety of programming languages and systems, and the whole formal aspect and the whole rigorous aspect of D would be well served if we got somebody in the research field to look at D. So we have we have a couple of people who gave talks today, this conference, this edition, about how they use D in academics as either as an implementation language or as an object of study. And this is awesome. We need much more than that. And definitely, we need to improve our corporate outlook. Was that funny? Outlook. Oh, okay. Oh, damn. Okay. Can't believe I said that. Our corporate, friendliness. So we should really be corporate friendly, and by that I mean, again, professional execution. We should have predictable releases, stability in the language. We need to have like really operational efficiency and kind of make things in such a way that corporations are going to understand. It's not only like sociomantic. We sort of we're able to get ROI from D, but it's a slam dunk to make money with D. We should get to that point. And I believe for many corporations, many companies, Silicon Valley and beyond, I do think that there's absolutely humongous opportunity to essentially like use D as a strategic advantage compared to other companies. This is a great sword to fight with. This is a great samurai sword to fight with, right? And it has a machine gun in it, right? See what I'm saying? So what did we talk about? We talked about aspirations. What do we want? What are we about? What do we like to? How do we like to do things? We aspire for a language that's comprehensive and is principled and is very practical at core, right? And then we talked about vision. Like, where do we want to go? What are we looking at? When we look like, in the typical like North Korean statue pose, right? When we look like that, what do we see? What's the shiny hill what's the shiny seed on the hill there, right? And our vision is that we should move forward with a more stable, more powerful, more compelling language and a universe of tools surrounding it. And last but not least, it's all about people. So we can make it happen. And let me end with a sort of another anecdote, if you can resist. It doesn't start with when I was born. It doesn't start with when I was at Boeing. And it doesn't start with when I was in the military. So rest assured. The story goes like this. To go from point A to point B, which autonomous organism does it with most efficiency? Who knows?
Ants.
Ants. No.
Big enough to be both ends at the same time.
Again?
The one that's big enough that it's already at both places at the same time.
That reminds me of that whole speed of light theory. What if you have a bar that's as long as the distance you want to go and you just nudge it a bit? But that's a fallacious argument anyway. So anyhow, what's the most? It's not the ants. So ants are up, but are not there. Birds? Which birds? Okay, so Andrew. Birds, okay, there's a bird. Okay, it's a bird. Albatross. Okay, I'm not very good at birds, so I'm not sure if it's the condor. Is the condor. I hate that condor, right? It's the condor. So if you kind of classify animals by the efficiency with which they get from point A to point B, condor comes first, goddamn condor, right? And humans are kind of crappy, like kind of third from the last, completely ridiculous, right? So humans are not good at going from point A to point B efficiently. Okay? And the condor, the blessed condor just does majestically flying, eating a fly on the road, that kind of stuff, right? But I destroyed my thunder. Hold on. But a human on a bicycle, that blows the freaking condor out of the water, okay? It knocks the socks off the condor, okay? It's like 10 times more efficient than the condor, all right? A human on a bicycle, which means the laws of physics, kind of, the inherent limitations of this world, right, and what nature can do is they dictate what's possible and what's not, right? But they don't get to determine what's awesome and what's not, right? The bicycle is awesome because it means the efficiency is not in the condor, it's in the minds of people. The efficiency can be found here. It's not the wings and all that good stuff, right? No, it's here. You can find it here if you look for it. So let's go together, invite the bicycle. Let's do it. Thank you. Take questions.
Yeah, what the plan in general to address breaking change in the language in the future?
We have been increasing, we've got like exponentially more conservative about accepting breaking changes. And that trend is going to continue. So we're going to be hawkish and more hawkish and more hawkish about breaking changes. We believe the only kind of breaking changes we're going to accept are the high yield ones, such as the switch statement was crappy and we're going to fix it and we found bugs that way. So this is a high yield breaking change that I think is going to uncover only bugs. But other than that, I think we're going to be very, very, very conservative, increasingly so about breaking changes. We do plan to design around, to kind of change the language design to fix things like qualified bit, post-blit, and stuff like that, like all the rough edges of the language. But as few as possible, breaking changes. Questions? Hey, Tan.
Thanks. When are we going to see a second edition of TDPL?
When are we going to see a second edition of TDPL? I've had a lot of thoughts about it, including self-publishing and taking care of my own Kindle edition and that kind of stuff. This may become as well a copyright issue. I think TDPL was conservative enough about a few aspects of D to remain relevant for a good while going forward. Of course, once large changes in the language are going to impose it, we're gonna print it again. Until then, this whole effective D idea, where's Stefan? This whole effective D thing and this whole idea of a book that does not describe the language as much as what you can do well with the language and how you should do it. This is a very exciting idea. Ali has a book in the makings with, Ali has everyone knows you already, right? All right, yeah, awesome. So he has a book on teaching D to sort of first-time programmers. So this is a great thing. A lot of people should know about it. But also effective D sounds like a really cool thing, including, I'm not thinking effective D is not like effective C++ that kind of avoid like half of the language, that kind of thing. It's going to be more like, patterns in D, like David has had this awesome talk earlier today. This kind of stuff, like how can you use D effectively in interesting patterns, idioms, and stuff like that. To my regret, Ali, I'm not going to include where to put the braces. Did you notice that all my braces were on the same line? You're like, yeah, or the knife. Oh my God, I can't believe this. Questions? Don't let me hanging. Ben.
So a lot of the most successful programming languages and open source cultures kind of have a benevolent leader in charge, and D is the only one I know of that kind of has the co-conspirator to leader society. What do you guys do to avoid becoming, like RIM, where, left hand and right hand, just can't go in the same direction? Because sometimes you just have to just say like, I'm the charismatic leader, and this is the way we're going.
Well, I'm glad you asked. Do you have an answer to that?
I don't really know how to answer that, because I guess to our great advantage is first of all, we do have the same vision for D and the same goals. And so when we disagree, what we try to do is convince each other that our proposals are more congruent to the goals than the other guy's proposals. And we have, well, first off, we're friends, and that helps a great deal. And
we're friends? Okay, sorry about that.
Oh, that was low. And,
Yeah, we're
you
not
know,
friends now, starting now.
You know, we insult each other and though we don't mean it. You know, we yell at each other and we don't mean it. It's all that kind of stuff that it's just a good working relationship, and we talk all the time on Skype. And Skype is the most amazing vehicle for collaboration across distance. So, you know, I know Andrei is always back and forth between California and Boston, and you know, I never even know where he's from, where he is when we're talking on Skype.
Right.
But I think the overriding thing is we agree on what D ought to be. And we also have a bit of a yin and a yang. I'm
the practical
come
guy
from
and
the
the
practical
principal guy.
guy, and he's
The
from
principal
the proof
guy. I feel very good to be the principal guy and not the practical guy. Let me add a bit to that. I do think like this, if the times were different or whatever, we'd go down in history, have this couple of writers who kind of write together, and all kind of these brothers who wrote the music for Snow White in Disney. You know, I forget their names. And like they wrote like the smashing amount of great musical. Huh?
Rogers and Hammerstein.
Rogers? Doesn't sound like it. Anyhow, so they wrote like, you know, I'm not going to start singing here, but they wrote like the Snow White music. They wrote like the Chattanooga Choo Choo, whatever, you know, all this stuff, all these great songs, and they wrote them together. Anyhow, so I think here's what, to answer Ben absolutely directly. If it comes to if worst comes to worst, Walter's going to decide. This is a real. It's his language. I even have no pretense. It's his language, his baby. He's going to be the last guy standing, okay? That being said, we did have the largest source of disagreement between us got materialized in like this much of a skull in the D programming language book. Do you know where the skull is? Okay, so Walter was against array bounds checking in release mode. And I said, well, in release mode, if you want to be safe, you gotta do dynamic bounds checking. And we fought on this until I said, if this is not happening, I'm leaving D. And Walter's answer was, you win. I mean, it kind of ended the discussion. And Walter was so cool about it. He said, you win. And he added the dash no bounds check flag as a compromise to that situation, with which everybody's happy. You know, I think it's a good sort of system programming compromise to have an extra flag for bounds checking. But sort of, again, to answer directly the question, Walter is the guy. So if any bad decisions go about D, it's his fault, not mine. All right. I think we're all busy and tired and looking forward to the flight back home. Twitter questions. I actually took some questions off the mailing list. So there are questions about allocators, there are questions about the post-bleak constructors, there are questions about language stability, many of which I addressed. Now, you know, a few closing words. This has been an awesome conference. I'm really thankful to essentially like literally all of you. Our corporate sponsors, Sociomantic, Remedy Games, and of course, my employer, Facebook, who is really, and this was like a really good organization per my story about the AV guys. So this has been an awesome conference. I'm very happy that we sort of got to this point where we're at the end of 3 days, very intense, very inspiring, very good talks, very awesome people. So I would like to thank you. Give yourself a hand, and let's meet again next year. Thank you.
Clubs in hotels,